As the 2014 Sochi Olympic Winter Games fast approach, expectations for competitors reach new heights, especially for those competing in ski jumping. Ski jumping is a sport that requires participants to ski down an incline, launching from the bottom of a ramp in the middle of the slope. The requirements and opportunities are different for men and women. While the sport has been a part of the Olympics since 1924, this Olympic Games will be the first time women are included in the event. In the Sochi 2014 ski jumping event, men will be given 3 tries to reach their best distance, while women only receive 1 chance. At the same time, women are allowed only to compete on the 90-foot normal ramp, while men are allowed to compete in an individual competition on the 120-foot ramp. Skiers are judged by the distance they are able to fly through the air before landing. The further from their takeoff point, the more points they are awarded. The standard distance they aim to meet is called the K-line. The closest equivalent to this value in sports would be the par in golf. It's a probable outcome and the standard for judging each jump. If the competitor does not reach the K-line, he or she is docked points per meter they are short. If the competitor lands past the K-line, they are awarded extra points in addition to the standard amount given for reaching the K-line. Skiing for Team USA are Sarah Hendrickson, Jessica Jerome, and Lindsey Vonn. We also have Nick Alexander, Nick Farrell, Peter Frennett, and not pictured, Anders Johnson. Each of these competitors is employing various physics properties to make a successful run along the ski jump course. When they stand at the top of the ski slope, the skiers have potential energy without kinetic energy. Energy is defined as the ability to do work or applying a force over a distance. Due to the conservation of energy, as a skier starts to move, the potential energy is converted to kinetic energy. The faster the skier moves, the more kinetic energy they have, therefore lessening the amount of potential energy they possess. However, the potential energy is still present as the skier takes off from the ramp because it describes a skier's ability to move relative to the ski slope they jumped from. Whenever the competitor lands at the end of their flight, their energy is wholly kinetic. That energy is then converted through friction into heat. An easy way to illustrate the skier's ascent and conversion of energy is by using a toy car. While the car is at the top of the step, it does not move, so it has no kinetic energy. However, it has the ability to move to the next step down, giving it potential energy. As a force is applied to the car, it starts moving forward and falling down. Its potential energy is converted to kinetic. As the skier speeds down the hill, reaching a velocity of up to 90 km per hour, they build linear momentum. This quantity increases as the velocity increases because momentum is the product of a skier's mass times velocity. While the skier's mass remains constant throughout the run, their velocity will increase due to the natural acceleration of gravity. The increasing momentum can be measured in how many kilograms are moved over a meter each second, or kilograms times meters divided by seconds. The change in momentum of the skier as they descend the hill can also be referred to as an impulse due to the force of gravity applied constantly over time. The skier's launch into the air can be attributed to one of the longest-standing physics principles to date. Newton's third law states that for every action, there is an equal and opposite reaction. Therefore, as a skier pushes down on the ramp pushes back on the skier with equal and opposite force. This keeps the skier from pushing through the ramp and instead helps to push the person into the air. With this knowledge, you can safely impress your family as you sit glued to the ski jumping competition in the 2014 Sochi Olympic Games.